So good evening, all of you, and welcome to Cheenta. And let's start today's class. So today our plan is the following: that we will be we will be focusing on certain problems in statistical estimation because that's what we have done till now. And how much part you have done? How much part till you have done, guys? You have done completeness, guys, and sufficiency. Yeah. Can you please reply? So you have done unbiasedness, completeness, status estimation. What do you have you done? Minimal sufficiency, okay. And what else? Completeness and Demarco's theorem, very good. Ancillary statistic, okay, lovely. So you have done consistency. Did you do till now? Okay, fine. So let's discuss completeness and sufficient statistics problem. That the problems I have given as like we have given as homework. So let's discuss some of them. And also I will be discussing one of the problems and extending that problem how we can do it. Yeah, like the main idea of this class is like the problem solving aspects of sufficiency and completeness. So let's revise that, okay? It's super important. And those who have done classes before of mine, they will finding like those who have done the crash course class, they will be finding a like correlation with the things that I've already focused on. So that's good actually. So let's try to focus on sufficiency and completeness and the corresponding problems that we have given you in homework. Okay. So let me check the class room, the LMS. Okay. So okay. So we will be doing this set problem. Just give me a minute. Okay. Okay. So let's do this. So did you do criminal overbound, guys? Uh, criminal overbound is done. No. Okay. So this will be done this week. So, anyways, let's do the part that we can understand. So let's. This is from our assignment, and let's do this. Let's do this problem together. So x1, x2, xn from a random from a distribution with this probable density. So show that this is sufficient for theta. So let's forget about the criminal overbound. Let's focus on the sufficiency part. Okay, show that this is sufficient for theta. So can you tell me now that what is this? How to show that some statistic is sufficient? How to show this? Any ideas, guys? What do you think is a way to show this? So what is the first step? Find joint distribution. Very good. So the first is always find joint distribution. First step is always find the joint distribution. Find the joint distribution. Okay, so what we will do with the joint distribution? We will be using the NFT, the name and factorization theorem after that to find the sufficiency. Okay. So what does name and factorization theorem say? It says that if the joint distribution can be written as what? If you observe that if you condition on t, okay, that is the sufficient statistics t, then it will be independent of theta. Okay, and if you condition on if the rest part will be just a function of, so it will be like this, it will be a function of g of t times, so this part is independent of theta. Okay, after you have conditioned, sorry, so this part, there's an x part. So yeah, the idea is that you will be doing like this, given f theta of t. So this part is independent of theta, so it will be just a function of x and t. So this will be a function of x and t, and times the function of, which contains theta and x, theta and t. So which contains theta and x, you can say. Okay, so this is the basic idea. Did you understand the logic behind this? So this is the what is the name and factorization theorem says. Are you okay with this, guys? Are you okay with this? Like, I think you have done this. So are you okay with this definition?
It should be HT theta.
Oh, it will be G. I'm just sorry. Just give me a minute. So one is independent of theta. The other part is not independent of theta. Did you understand? Right.
Yes.
G theta. Another part is just it depends on x and t. Okay. So you can write this as
The statistics should not be in the PDF of H of X, in the X1.
this one. Okay. So I mean, given t, that is a constant, so you can tell that. So yeah, you're right in some sense. So together we can write it as h of just x. Okay, and here we can write it as g of the t comma theta. Now it's fine.
Yes, sir.
Good. Perfect. So this is the basic definition. Okay. So it's if and only if condition. So that's the beauty of it. So we will be using this to show, to find that it's actually this t is, if we can express in this format, then this t is sufficient. Okay. So for this we need to find first the joint distribution. So let's find the joint distribution first. So therefore the joint distribution f theta of x curl will be product of this PDF 1 to n, and which is turning out to be theta 2 to the power theta x to the power theta plus 1. So we have 3 to the power n times 2 to the power n theta times x to the power, so it's xi over here. So it's xi product of xi whole to the power theta plus 1. Is it fine with you guys? Is the whole thing fine?
Yes, sir.
Very good. So now we will be using this. So we have to remember, we have to write it in terms of what? You have to terms of t, and one is t and theta, the other one is just x. So just x part, so t and theta just x part. So here you can see the t and theta part is here. Okay, in fact you can consider the entire one. And just x part is just 1. So h of x times g of t comma theta. So this times so this is the h of x and this is the g of t comma theta. Is it fine with you guys? Did you understand this? I'm doing it very slow since you're starting out. Did you
Yes,
understand?
sir.
Okay, good.
Oh, but can we break it in terms of theta and to the power 1? Na?
Theta
The product of xi, which is raised to the power theta plus 1. So we can keep one product of xi to the power theta in the g of t theta.
oh, we can keep that, we cannot keep that. So that's why it's so like there is no
So
unique.
we can keep it now. I just want to confirm
Yeah, we
that.
can also keep that. But it's okay if you can like it's okay it to be one. Okay,
Okay, sir.
it I mean it's okay it to be one. So no worries. So yeah, we can keep that of course. We can keep that of course. So that's totally fine. And if you can observe it that the t here is what? Can someone tell me what is the t here? You can observe here.
Product of xi.
Product of exercise. Very good. So product of exercise is a sufficient statistic. It's a sufficient statistic. So but here it's something else is given. So we have found that t is a sufficient statistic. So can you tell me like any other result that you know about sufficient statistic?
Can we use exponential family?
Something easier than that?
Sir, one-to-one function of sufficient statistics will be sufficient.
Very good. So one-to-one function of sufficient statistic is sufficient. Superb. Yes, you're right, Mansi. Of S statistic is S statistic. Okay. And the next one is that if S is a sufficient statistic, sorry, if G of S is a sufficient statistic, it implies that S is a sufficient statistic. Okay. So these two results are really, really important. So using the first result over here, we get that log is a function. But let's check before we take log. Let's check if we can take log. So xi greater than 2, so we can take log. So this is positive. So therefore, so you see these things why I'm discussing, because these things will be not important in IIT. But if you are appearing for ISI, if you don't write this, then this will be like um, this will be like I mean there you will get your marks cancelled. Okay. So therefore log is the defined, and therefore log t is well defined, and it's a sufficient statistic also with respect to this. So we are also planning to like after this IIT JAM, those who are interested in ISI, we are planning to like hold some sessions for your written stuff. Okay, how to write properly in the examination. So that's important. Okay, so this we have done it. Okay, so criminal round you will learn it soon in your class, so that's very important. And if you have already have you attended our crash course class, then I already taught you last day. So do you want me to teach it? I think you have attended the class, so do you want me to teach it, guys? Like,
Yes, so we can do this.
so others, did you attend the criminal overbound? I think I should do this. I mean, it's your duty to attend the crash course. So I have done it there. So I should, I think you should do this. I should do this. Okay, so how to find the criminal overbound? I have given a step-by-step approach to that, right? So do you remember I gave a step-by-step approach to find the criminal overbound? So first is, so the algorithm to find the criminal overbound. What is the algorithm? The algorithm is the following. Number one, right? The joint distribution always. that is f theta of x curl. Second, find the score function, that is called score statistic. You can also write the u. So you can, why u? Because it's unbiased. So it's del dot dd theta log of f theta of x. So this is probability. So this will always be greater than 0. So it's on support, okay, on support. Why it's greater than 0. Okay, so number one, check that its check support is independent of theta. So it's independent of theta because x is greater than 2. So it's independent of theta. So first, write joint distribution. Second, write the score statistics u is there because it's unbiased. The third is, I have shown it in the crash course very clearly last day. So the next step is find the variance of u. Okay. Step 4, the CRLB is g dash of theta whole square by variance of u. Okay. So all of you remember the steps, guys? Do you remember the steps now? Is it fine, or did I miss anything? Yes? Any objections to this? So this is a CRLB algorithm, step by step. Anything you want to say, guys? Or is it fine?
Fine, sir.
Fine, very good. Super. So just remember the steps, okay? And as you know, this can help you find the UMVV. Okay, so there is a result as the Satej told in the class that is based on this. I will be repeating that. That is super important, and it should be mentioned in your it should be there in your cheat sheet. Okay, whatever your, so this is okay, so I'm just digressing a bit. Is that how to make use of the mock test, guys? So I have repeated this a long time and again. So make sure whatever mock tests, the important mock tests are all of them, but the super important are the 4 full mock tests. So let's say today only I was talking to one of the students, and she understood that after giving for mock test 1 that her C's and she was good in linear algebra, and she could easily do integral calculus, but she was not good in sequence and series. Okay, and also she missed a result where in one of the problems they need to use the result trace A B equal to trace BA. So I told her that, see, this is how you should make full use of the mock test, guys. Okay, how do you make full use of mock test? Whatever you understand, you think that this results, the solutions will be given, you will be talking to other students who will be giving, and you will be discussing the problems and solutions. So you will know that, okay, this results I am missing. So make your mock test, make your cheat sheet based on that. It can be a 100-page cheat sheet. Okay, it's totally no, it should be written with your hand, and each one of you should make your own cheat sheet. Okay, it can be 100-page cheat sheet also, it will be like coming down. Okay, and make sure you write all the results, and make sure you mark that which results you to apply in the examination hall. So this is the way you should proceed. And next mock test 2, math mock test 2 mein, you will be trying to make a strategy and correspondingly increase your like work upon your weak areas. Okay, so it's not a main mock test, so you can experiment a bit. And using this to mock test too much, so each one of like math 1 math 2 is there, prob 1 prob 2 is there, stat 1 stat 2 is there. For each one of each mock test you will be having a set of cheat sheets, and just refer to those before the full mock test. That's it. That's what I want you to do, because this is a good strategy, and that's why instead of keeping one topic mock test, that is mock test 1, math mock test 1, prob mock test 1, stat mock test 1, I have kept the 1 2 1 2 1 2, and then the full mock test 4, so that you can get time for preparation and making it making an optimum strategy. and also aim for 60%, okay? And don't aim for 100%, it's very unnatural. Aim for 60%, because you know that all of the students are like, all the people who have come here, give lectures and suggest the preparation strategies, they have aimed at 60% is a very good mark. So if you're aiming for 30 questions, aim for 10 questions and 18 questions that you think are really really good for you, okay? And this is the only strategy you need to understand. You need to aim for 60%, not the 100%, okay? That's the idea. And that's it. And yep, so let's not waste our time. So I just told you because um yeah, so just to mention that how to attempt the, like, mock test, how it can help you. Anyways, coming back to this, um let's find it out. So we have found the geometry of the function. It's like this. So you can write it t. Okay, you can write this as t. Okay, so you can write it as t theta to the power theta plus 1 into theta to the power n into 2 to the power n theta. Okay, that's totally fine. And this, so let's write down the steps correspondingly. F theta of x curl is nothing but t to the power theta plus 1, theta to the power n, and 2 to the power n theta. Very good. So next step is finding the u, the score statistics, that is d d theta of log of f theta of x vector, and you get that it's what? And you take the log, so you get d d theta of theta plus 1 times ln t plus n log theta plus n theta log 2. So if you do the dd theta, you get ln t plus n by theta plus n log ln 2. Very good. So you get this, and next is that you need to find out the variance of u. Okay, so you need to find out variance of this. So these are constant essentially, so you need to find out variance of log ln t. And I think the question mentions an unbiased estimator, so yes. So log ln t, and you need to find, and g of theta is log theta over here. Okay, so did you understand till this point of time, guys? Any doubts? I hope everything is clear. Any doubts, guys? I'm doing it very step by step so that you understand it well. Any doubts? Did you understand till this point of time? Did you understand you have to find out log variance of log ln ln t? Yeah. Yes or no? At least tell me. Okay. Thank you, Pratiksha. Very good. What about others? Okay. Swagata, are you understanding? Prama, Tishika, Nikhil, Orko. Very good. Okay. So this is variance of u log ln t. That's good. So now let's find out the variance. So you know that log ln t is not a, like, it's not easily find, like, you may not find that easily, or maybe you have to use Jacobian or stuff like that. Let's explore that. Okay, let's explore that. And so let's explore. So whenever you're trying to find, as I told you, when you're trying to find the variance of something, always make sure it's an easy way out. Okay, so there must be an easy way out, or there may be an easy way out. Always go look for that. That means you try to connect this log ln t to some known distribution. You may not know that, but that's the first step. Always connect to known distributions. That should be the first step. Then you should try out Jacobian and other long methods, like the first principle methods. First, you have to understand whether, like, maybe it's a known distribution. So do you find a known distribution in this, guys? Do you see it's a known distribution? Do you think it's a known distribution? Yeah. Do you think it's a known distribution, guys? No? Okay. Okay. So if you think it's on a known distribution, let's compute this then. And if you want to compute it, let's check out. So you see, log t is nothing but summation of k from 1 to n ln xk. Okay, so let's find out log of xi ka distribution, and we can easily find out. Okay, so Rishabh, another suggestion. Rishabh's suggestion is that if we can differentiate it, we can find it out again. If we differentiate it, that's actually a good idea. I like that idea. So there's another result. Yeah, that's actually a better idea, I guess. Yeah, let's do that again. Yeah,
So it's minus double derivative. Huh?
yeah. So there's another result, that is variance of u can be also written as minus of expectation del square del theta of this log this. Okay. So what Rishabh is telling. So we can use this also to find it. And if you see, it's really easy over here. It's minus n by theta square. So it's minus minus, it's n by theta square. That's very good. And because it's a constant. So therefore, very good. So therefore, we have found out that this is equal to n by theta square. So what will be the CRLV? The CRLV is what? G dash of theta whole square by n theta square. So it's 1 by theta whole square by n by theta whole square. So it's 1 by n. All of you got it, guys? Any doubts? All of you understood it?
Yes, sir.
So that's a very good suggestion. Thank you. Okay, so coming back to this now. Okay, so that's good. So do you want me to? So it's up to your choice. Do you want me to show you that variance of u is actually equal to this theta, so that you can get it? That, I mean, in terms of this result, do you want me to compute like it's a transformation problem? So I was thinking it will also revise your functions of random variable knowledge. So do you want me to do that, or do you want me to continue to the next problem? Like, do you want me to compute it and show it to you that it's actually that case, or do you want me to move on to the next problem? So GX, it's told over here that find an unbiased estimator for ln theta. So GX is log x, that is g theta is ln theta. Yeah. Okay, so since you are not interested, I will move on to the next problem. Okay, so what's the problem here? Let's see. The next problem is based on, okay, this is like one parameter. It's like a curved exponential family. So Okay, so here is also another sufficient statistics problem. So let's do it from the beginning. How to use the sufficiency? I should like you should be very confident in sufficiency. Okay. So the question is that here two type of questions two type of problem solving you are addressing. Number one, how to show something is sufficient. That we already know. But there's another problem here. How to show something is not sufficient. Is not sufficient. So we know we can do this by NFT. But how to show that something is not sufficient? Any ideas, guys? So this is a problem you am using to tackle this like idea. So how to show something is sufficient? We know it's NFT. We have given the algorithm step by step over here. The steps. The question is that how to show something is not sufficient. Any ideas? So let's check. Let's check it. Okay, let's check it. So let's find it out. So x1 x2 xn follows normal mean mu and variance mu. Mean theta, variance theta. Okay, so let's find the joint distribution. That's the number one step. Find the joint distribution. That's step number one always. And we write it down. So it's product of I from 1 to n, 1 by root 2 pi root theta. Theta is greater than 0, of course. Exponential minus half x minus theta by root theta whole square. Sorry, whole square. Here is xi. So if we multiply this, we will get so whatever this constant will be there 1 by root 2 pi whole to the power n. This constant will be there. Then there will be this theta to the power minus half is there. So whole to the power n will be minus n by 2 times exponential will be summing up. So e to the power so exponential minus summation of half summation of I from 1 to n xi minus theta whole square by theta. Okay, so let's term this as constants. If you remember, this is the part of you can understand this is the part of hx and this is the part of g of t comma theta. So we have to find out and you have to find a representation of this, a good representation of this. Okay, even if you don't remember exponential family,
So wouldn't it be easier by using exponential family?
yeah, it will be easier using exponential family, but I'm doing it again because exponential family is easier, but I'm doing it here because first like this step I'm like writing it very formally. So exponential family you have to expand it now.
Yes.
So when you expand it, you will get it like exponential family is very easily understandable. So it's the same thing like NFT is same thing for exponential family. So we just expand it. So expand it like so it's the same thing exactly exponential family ka. So you don't have to work harder. So exponential family के लिए when you need complete and sufficiency together, that is when it's important for exponential family. So otherwise it's not the same actually. Okay, I mean you need no more work. So anyways, let's write it down. So here you can understand we need to find out and simplify this. If we expand it, it's xi square plus theta square minus twice xi theta by theta. Simple. And if you write it down, so you get exponential minus half 1 to n xi square by theta minus n theta by 2. So its theta is cancelled and there n, so n theta and by 2. And here you're getting plus summation 1 to n xi. So you see that this is getting out as of constant of xi. So here there was another term, 1 by root 2 pi whole to the power n times theta to the power, like if I write it theta to the power here, so it's times theta to the power minus n by 2 times this. So you can understand easily out here that this will be going out. So you can just write it out here. Times, so you can just write it this thing out here. Exponential minus summation of xi I from 1 to n times this weird stuff. So you can understand easily now this is the g of x part or h of x part, and this is the g of t comma theta part. And you can easily understand from here that theta t is equal to what? You can understand t is equal to, you can just take it out here, 2 theta. And easily understand t is equal to nothing but summation of xi squared. All of you understood this, guys? All of you understood this step by step idea? Counter example of, oh, acha, Tishika's, okay. Yeah, counter example. Let's see how we can do this. Did you understand this part, guys? All of you, how we found out the sufficient statistic? It's very easy, okay? So
Yes, sir.
yeah, very good. So now we have seen that summation xi square is sufficient for theta. It's fine. But what about the other cases? So we have found out summation xi. Now we know results about sufficient statistic. That one-to-one function is this, and gs is sufficient, then s is sufficient. Okay. So also there are a lot of other cases. So I have done the results with you guys. Let me do it again. So sufficient statistics result, I have done it in our crash course actually. One-to-one function is done. GS implies S, that is also done. The other cases are if T is sufficient, then if you take any T, comma, any other function, U, this is also sufficient because it contains T. You can understand that, yeah, this is also sufficient. Okay. And yes, so this is also sufficient. What else? और तो कुछ नहीं आ रहा दिमाग में, और तो कुछ नहीं आ रहा दिमाग में. Anyways, okay. So let's check this. So is summation xi sufficient for theta? So how do you show that this is sufficient or not? How do you prove that this is not sufficient? How do you show that something is, this is sufficient or not? How do you show that? How do you show that this is sufficient or not?
I think we can do this by like the joint distribution divided by this summation xi distribution. If it is not constant, then it's not sufficient. The ratio of that.
Okay, फिर से बोलो.
Like in the theory classes, now students are told that if we need to check a statistic is sufficient or not, if the given statistic,
Yeah,
the ratio of joint distribution
yeah,
and the given statistic distribution.
okay,
If it is constant of theta, then it's sufficient, otherwise not.
okay, perfect. Uh, so okay, so you can check that. Yes, you can check that, and yes, you can check that. You can check that. You can check that. Is it an if and only if condition?
Yes, sir, if the ratio is constant, then sufficient, otherwise not.
So the result is what?
The joint distribution over the distribution of statistic.
Yes.
If it's constant with respect to theta.
So this is what? This is right. This. So if this is constant to theta, then it's sufficient or not. Perfect. So we need to find given t. That's it. So that's the first principle. How to show it's sufficient or not. The first principle says that this at f theta of x curl given t is independent of t, then it's sufficient, else not. So we can do for the first principle. Sorry. Very good. Very good. So do you want to compute it here? So you see you have to compute it here, right? So you can also understand that this is nothing but f theta of x curl by f theta of t. So here it's summation xi. Okay, but you see this can be a little bit harder. What do you think about this? How we can show that?
Sir, I have a doubt.
Yeah, yeah, bolo.
If the A particle comes out to be sufficient,
Yeah.
then can summation, the C part can also be sufficient.
Why do you think it cannot be?
No, that's what I was confused about. Like it can be, no?
No. I mean, it can be, it cannot be. But you have to give me logic.
Like if two are sufficient, then their sum is also sufficient.
क्या यह कहाँ से मिला रिजल्ट तुमको?
No, I'm just asking. Like, I'm not
Okay, no,
sure.
no, it cannot be told like that.
Okay.
Okay, so do you guys know about minimal sufficiency? Do you guys know about minimal sufficiency?
Yes, sir.
Okay, so can you tell me the definition of minimal sufficiency? Tell me the definition of minimal sufficiency.
Like definition is basically like if we have two sufficient statistics, the one of them will be like function of the other. That is, if we have tx and t dash x, like one of them will be function of the other. So yeah, that's like the definition. But to solve it, that's different way.
Okay, so what is a different way? So how to find a minimal sufficient statistic?
Yeah, so we take two sample points like f of x given
Okay.
the parameter.
Okay, yeah. Go ahead.
Theta.
You're totally correct. Go ahead.
Yeah, so with those we take the ratio of those two, and if if we get that, they should be if they should be constant, and we should get t of x equals t of y. That's the condition.
Very good. Very good, Nikhil. So the sufficient statistic, minimal sufficiency is T is called minimal sufficiency in some sense that you see this condition that if GS is sufficient, then S is also sufficient, right? So there should be it's like there should be something minimum exactly, na, such that every sufficient statistic is a function of that. You see, it's like if there is a statistics T, sufficient statistics T, GT, then it implies that जो अंदर है वो भी sufficient है. So अगर अंदर वाला और एक sufficient statistics का function है, G is equal to H of S, then S is also sufficient. If S is a sufficient, so it's like composition of functions. So as we go under like more into it, there will be a minimum one, right? So that minimum one is called minimal sufficiency. Now to find that, it's like this: if f of theta x is equal to this, then this is minimal sufficiency. So let's find a minimal sufficiency over here. So we have found out that it's this weird stuff. Okay, so if we just divide it by another y, so what will happen? This 2 will get cancelled, the theta part will get cancelled, and this one will be there. So let's write it down. Is exponential minus half summation I xi minus theta whole square by theta by, oops, what I'm writing. So it's exponential minus half summation of I from 1 to n xi minus theta whole square by theta by exponential minus half summation from 1 to n xi minus theta whole yi minus theta whole square by this. Okay, and you can see that let's see what happens. You will get a lot of stuff like this, exponential. Let's write it down what we have got over here. 1 by theta. We have got t. Okay, minus n theta by 2. So then theta by 2 will get cancelled, and minus summation xi is also there. Okay, let's call it s. So t is equal to so you get 1 by 2 theta. Okay, plus sorry minus S. Okay, this is S of x, S of x by exponential minus 2 by theta T of y minus S of y. Okay, so what do we get over here? We get that exponential minus 2 by theta T of x minus T of y minus of S of x minus S of y by whatever is equal to 0, is equal to some constant. So it will only be constant if and only if what? If both of them are 0, right? Otherwise, it will not be a constant. You can easily understand that. If one is 0, it will not be a constant. Both of them must be 0. You understand? So therefore, so you can also tell it could be as just a constant. Okay, so if that's a constant, you can just replace it by, you know, minus c by 2 plus c by 2. That's the in that way. Okay, so it will be tx minus c by 2 plus c by 2. So that will be the one-to-one function. So therefore, it's only if and only if this two happens together. So a minimal sufficient statistic is t comma s. Like a minimal sufficient statistic is summation xi square and summation xi both together is a minimal sufficient statistic. Okay, and you can easily understand a function of a minimal sufficient statistic is always sufficient. So summation xi is sufficient. What do you think? Sufficient? What do you think? So did you understand this is minimal sufficient stuff? So we have found that summation xi square comma summation xi is minimal sufficient. We know that summation xi square is sufficient. Is summation xi sufficient? That's my question to you. Is summation xi sufficient for theta? Tell me, is summation xi square sufficient for theta? Summation xi square sufficient for theta. Is summation xi sufficient for theta? How we can show it from here? Is summation xi sufficient for theta or not? We took it out over here. We could include it over here. How we can show summation xi? So yeah, tell me. So how we can show summation xi is sufficient or not from here? Tell me. Tell me how we can show summation xi is sufficient from here. It may be hard to show. I mean, no, you will get xi square and it will be get xi. So is summation xi sufficient? So I did you understand this, guys? Did you understand this? Did you understand? I may have done a mistake. So did you understand this? In fact, I have done a mistake, and you told yes, it's correct. Can you tell me what is the mistake I have done? Can you tell me what is the mistake I have done? Can you tell me what mistake I have done? The mistake I have done is that here T is minimal sufficient, not S. What is the mistake I have done? That's why I did it. So that you can understand that what mistake I have done. Let me write it down here properly. See, so it should be independent of. कहाँ जा रहे भाई? So let me clear it. So let me write down the full stuff. It's told that exponential minus half by theta, tx minus ty, okay, minus sx minus sy, okay, by exponential minus 1 by 2 theta ty. Okay, that is already done. Yeah, I think that is already done. So yeah, so this is equal to constant. So here x and y are fixed to numbers. So this is a constant with respect to theta. So why did we consider that? So this just implies so we'll be only taking this part. Okay, because this contains constant, this it is not zero, this will be a function of theta. So therefore, tx must be equal to ty. You see, this is the full logic. So the previous logic was flawed. Just because there is sx minus xy doesn't mean that it should be that way. Okay? So it is this way. This is the full logic. Here is how we'll write in PSB path. So it's minimal sufficient just because, and it has to be zero, otherwise this will be a function of theta. This is equal to E. So this is if and only if this. So therefore T is minimal sufficient. Summation xi, not S. So T is minimal sufficient. Because this is a mistake people make. That's why I told it. And I did that deliberately. So you can understand over here that summation xi square is minimal sufficient. But how does that help? Here, how does that help? At all. The result is that any sufficient statistics S is a function of the minimal sufficiency statistic. Okay. So therefore, the question is that is summation xi can be written as a function of summation xi square? Can be written like that. So therefore, you can ask this question, which is easier to solve. I will show you how. Is this is a function of sufficiency? So this is false. You can understand. One, this is sufficient. So therefore, you are trying to understand if this function, if summation of this plus xi square a function of summation xi square. Okay. So if this is a function, then you can write it as summation xi is also this, which is another function of summation xi square. So therefore, if this is sufficient, this must also be sufficient. If this is not sufficient, this is also not sufficient. Okay? Did you understand this, guys? Are you understanding, guys? Shana, Orko, Mansi, Nikhil, Paulami, Pratiksha, Rishabh, Tishika. Are you understanding this? This
This
is
last part, this summation xi plus xi square.
sure, sure, sure. So I have not showed anything, but I told like this. So I told like we have to show if this is a function or not, f1 and f2. Okay. So I am telling you that if this is a function, if this is a sufficient statistic, if this can be shown like this, then it implies that this is equal to f2 of summation xi square minus summation xi square, which is equal to another function. It's a subtraction of two functions of t, na? So it's like ft minus f2t minus t. So it's like another function of t, summation xi square. So that means if this is sufficient, if and only if this happens, then summation xi is also sufficient. If this is not sufficient, then this is also not sufficient. So we have to just show one of them. That's it. Did you understand now, guys? Shana, Orko, Mansi, Nikhil, Paulame, Pratiksha, Proma, Tishika, Rishav. Did you understand sufficient, minimal sufficiency? That is very important. This is how you show minimal sufficiency, this step. It's very easy to show. Baki didn't understand? Tishika didn't understand?
Oh, so once I need to look at minimal sufficiency again.
So yeah, tell me, I will tell you what is the problem you're facing. Tell me.
No, no, sir. Actually, I need to understand that concept again. I don't have that much clarity.
Okay, but I told you the algorithm, right?
Yes, sir.
Did you understand the algorithm?
Yes, sir.
Okay, do you understand the way it's done?
Yes, sir.
Yeah, so I mean, I could have discussed the theory, but I think like it's not like, there's not much time left. So
Yes, sir.
yeah, you can see the recording. If you don't understand, you can ask Uttran sir or you can ask me again. Okay, next class. Okay, so all of you understand the algorithm. So here it's in the problem solving class. I am sharing with the algorithms. Okay, so and how to prove it. That's my like job. So therefore, we have to just show that one of them is minimal sufficient, or one of them is a function or not. So is summation xi a function of summation xi square? How do you show that? Tell me. It's a high school mathematics problem. Is summation xi the high school mathematics, but yeah, is a function of summation xi square? And it written like this. For all xi, remember. You see, I'm giving you the proof of this for all xi. No, xi are it's an n-dimensional function. So how do you show? This is a very interesting problem. Is this is a function of this or not? So whatever number you take, is this a function or not? So iska. How do you show this? Is this is a function or not? How to show it's not a function? This is a very interesting problem. How to show? So let's say all xi's are 0. That means f0 must be 0. So it's called functional equation. The question is, does there exist a function such that this is equal to this or not? And this is all greater than equal to 0. This is non-negative. Okay. So anyway, you can show there is no function like this. So let's do it for two numbers, x1 plus x2. Can you show it cannot be a function of this? Does there exist a function like this for all such x1, x2? Is it possible or not? This is a high school mathematics problem. Is it possible or not? What do you think? f of x plus y is equal to x plus x square plus y square is equal to x plus y. Does there exist a function like this or not? So whatever x and y put in, you will get x plus y. Okay, let's do it for one dimension. Is there a function like this? F of x square is equal to x. Is there a function like this? Just for one. Put xi, all xi to be 0 and one of them keep it just like that. See if x is equal to f of x square. So does there exist such a function like that or not? Tell me. Does there exist a unique function like that or not? Tell me, guys. You're all high school pass out.
Sir, absolute value of x square.
Okay.
I mean, yeah, root x like that.
Okay, root x. So you take f of t to be what? See, first of all, understand f ka domain understand. F ka domain is 0 to infinity and it's going to minus infinity to infinity. So my question is that f of 2. So tell me, like, f of x का कौन सा वैल्यू 2 लेगा and f of x का कौन सा वैल्यू -2 लेगा? Tell me. F of x का कौन सा वैल्यू 2 लेगा, f of x का कौन सा वैल्यू -2 लेगा? So you can understand that if there exists such a function, then f of 4 must be equal to also 2 and f of 4 must be equal to also -2. So this is not a function. You see?
Sir, but what if we take only the modulus that is in root x, but x has a mod?
This one, or just a positive one?
Yeah, exactly.
Yeah, it's a function, but you see that xi's are normal theta comma theta, so its range is minus infinity to minus infinity. So it will only take 2, not -2, but it needs to take 2, right? -2, right, Nikhil? So tell me such a value. It's not possible, right?
Yeah, in this case, not
Yes.
possible. Generally,
Yes,
just
exactly.
other.
If it was there that its indicator x greater than equal to x greater than 0, then this would have been a good solution. All of you understood it's a high school mathematics problem, guys. It's a very beautiful problem. Did you understand the proof? All of you understood it, guys? Shana, did you understand? It's a very interesting problem. So how to show some function is not sufficient? The only way to show it is that find the sufficiency, minimal sufficiency, and show that it's not a function. Simple. The only way to show it is that it's an if and only if condition. A function is sufficient if and only if it's a function of minimal sufficiency. So how to show a function is not sufficient? This way. How to show a function is sufficient? MFT. So it's done and dusted. Always you can find out whether a function a statistic is sufficient or not sufficient. Did you understand, guys? All of you understood it? This whole algorithm? So let me write down the algorithm. So sufficiency. The algorithm is this. Prove sufficiency. How? Find joint distribution. Use NFT, Neyman factorization theorem. Disprove sufficiency. Find find is equal to constant if and only if tx is equal to ty. 2 is find t. 3 is s cannot be a function of show that s cannot be a function of t. That means S is a sufficient statistic. S is not sufficient. And how to show? The best way, the easiest way to show is that take one variable. Take just one variable. Like take, there will be a lot of functions. Just take one sample, just like I did it over here. Okay. So take one sample. That's the hint. Take one sample, and that will reduce down to one variable function, and that will easily make your way out. Did you understand this algorithm, guys? This is a very well proved algorithm. I showed you. Did you understand? Write a boom if you understood the whole stuff. So there is no problem that you cannot do now. You can do every problem now of sufficiency. Okay? You can do just each and every problem of sufficiency now. Perfect. So remember this algorithm. How to disprove and prove sufficiency. This is the way out. Good. Very good. So unfortunately, there is no such, like, there's other results like for, I mean, exponential family, it's easy to find out that the t is always minimal sufficient. So you can use those results to finally find out, plus the properties of sufficiency. Okay, plus the property of sufficient statistics, you can find it out. So these are all the results of sufficient statistic. Okay, these are all the results of, I mean, all the, like, using this result you can prove sufficiency always. Okay, the next part, completeness. And I already given you the algorithm to find the CRLV. So you know the algorithm of CRLV. That's done. And what else? Let's check. So I am not doing any sufficient statistics problem. Okay, last day I have done UMVV, so I will be doing this problem. Last day I have done UMVV in my crash course, so I'll be doing this problem. So x1, x2, xn follows beta 1 comma theta. Show that t is equal to summation xi is complete sufficient, and hence find the UMVV for the following parametric functions. Okay, so when you're using complete sufficiency to find out parametric functions, you use Rao-Blackwell theorem. So how to find the UMVV? So there's an algorithm to find the UMVV. Number one algorithm. There are two algorithms. Using complete sufficient statistic, and they're using CRLV. Okay. CRLV says, देखो, if, just give me a minute. Just give me a minute. CRLV says, देखो Ava, it's very simple. Just give me a minute. Yes. CRLB says if you get an U, so you do what you, sorry, not U, so you do del theta log of f theta, you take the U, the score statistic. Okay. If you can write it in this format, some A of theta times some, some W of X minus, so of UMV of, let's say you're trying to find G of theta. So if you can write it as in this format, then this is UMVV. Number one, why this is UMVV? First of all, you can show this attains the criminal over bound. And second of all, you can easily understand this expression of u is 0. So therefore, this expression is 0. So wx of minus g theta will be, I mean, this is also unbiased. So it's unbiased and it attains the criminal over bound. CRLV. It attains CRLV and hence it's EMVV. This is the result I was speaking. Another way using complete sufficient statistic, it's easier because in many cases you can easily find out the complete sufficient statistic, exponential family and steps like that. So in this case, how do you find out? You find out number one, T, this is complete and this is sufficient. Second, you find the unbiased estimator. So you try to see first of all that this is 2.1. Let's say if there exists a small easy transformation, or let's say multiplying by a constant, okay, or adding a constant. Okay, is any such function is there such that g of t, expectation of g of t is unbiased or not? Not g of t, let's say h of t. So you try to find out a h of t which is unbiased or not. So one way is to small transformations, easy transformations. The other way is take any unbiased statistics u, or let's say any unbiased statistics u, or let's say u dash, whatever. Take an unbiased statistic and calculate expectation of u star given u dash given t. So either both of them are UMVV. Any one of them must be UMVV. Okay, and since it's a complete statistic, it will ensure that the UMVV is unique. In this case, it will ensure it's unique. In this case, it will not ensure. In this case, it will ensure. Did you understand the algorithm, guys? The step by step. This is the algorithm to find the UMVV. I've told you the algorithm to find the sufficiency and non-sufficiency. This is the algorithm to find the UMVV. Did you understand, guys? So let's apply this algorithm over here. Okay, so I've used this algorithm over and over again. So let's apply this algorithm over here. So since it's given complete sufficiency, it will be easier to find out using Rao-Blackwell theorem, Rao-Blackwell and Clement-Chaffee theorem. Okay, which I have taught you in the crash course. So B p theta. So let's find out first. In both the cases, you have to find out the joint distribution first. So find out joint distribution. So B1 theta, can you tell me the distribution, what it will be? Beta 1 comma theta. I myself forgot the distribution formula. Let me just check that. Beta A comma beta alpha is beta 1 comma beta is, just let me check. It's 1 minus x whole to the power theta minus 1 by beta 1 comma theta. So that's like 1 is that, theta is, so it's theta. So it's by theta. So it's, yeah. So it's f of theta comma x is product of 1 to n theta times 1 minus x whole to the power theta minus 1. Do you think it's correct distribution? I think so. I just checked it. And theta, and of course theta is between 1 and 0. Very good. So if you have found the product, so let's find it out. So it's theta to the power n times product of 1 minus xi whole to the power theta minus 1 and 2 It's take the del theta of log this, so you get, oh no, wait. So this is a complete sufficient statistic. This is a complete sufficient statistic. Let's show that. So we'll show it from the first principle. So sufficiency, it's easy to show. I'm not doing the sufficiency part. Am I doing it correctly? Product of this. So yes, I think this is, yes, I think we are doing it correctly. Just give me a minute. Just give me a minute. Did I do it correctly, guys? Did I write it correctly? It's Bernoulli P. What is Bernoulli P? Oh, okay. Oh, wait. Um, so if we take T, am I doing some mistake? Okay, yes, you're right. It's not beta. It's binomial theta. Yes, you're right. Thank you. Yes. So f of theta comma x curl. You can understand. You can write Bernoulli, right, product of 1 to n p to the power x1 times 1 minus p to the power 1 minus x1. You can write like this. You know that. And thank you, Rishabh. Yes, just struck me. And if you do it, it's summation of xi times 1 minus theta sum n minus summation of xi. You can easily understand that it's equal to 1 minus theta whole to the power n times theta by 1 minus theta whole to the power summation xi. Yes. So therefore, you can easily understand that this is sufficient. Okay. So you can understand that summation xi is sufficient. Let's prove it's complete from the first principle. You can always do it from the exponential family, but let's do it for the first principle. So first principle tells that if f of summation x, so what does completeness mean? Completeness means that t is complete, expectation of g of t is 0 implies g is equal to 0 on the support of t. I mean with probability 1. So let's check that. So expectation of GT. So T is what? Summation xi, which follows binomial n comma p, n comma theta, right? Because each one of these bound only in 1 comma theta, binomial 1 comma theta. So expectation of g of summation xi is what? Using the Lotus principle, we can write it as what? Summation of, so if t from where? T goes from 0 to n, right? Into theta to the power n into 1 minus theta to the power t into 1 minus theta whole to the power t whole to the power n minus t, right? You understand T is a binomial over here, so here it follows by Lotus. We don't need to calculate the expected a whole thing of like the distribution of g of t. So this is equal to 0. If this is equal to 0, then what we know? Let's understand that. This is equal to 0. So we can write it as this. So we can multiply. Observe that we can divide it by 1 minus theta. Theta is less than 1. So if we divide by 1 minus theta whole to the power n, so it turns out that it's a whole to the power t is equal to 0. Okay, it's a function of this. Okay, and you can easily understand it's nothing but a polynomial in theta by 1 by theta. So if you put it, it's like g of 0 times theta by 1 minus theta whole to the power 0 plus g of 1 into theta by 1 minus theta whole to the power 1. So it's a polynomial theta by 1 minus theta. So therefore, this is the polynomial. This implies that the coefficient is equal to 0. That means the coefficient must be equal to 0. Since it's a polynomial, it cannot have infinite roots. So g of t is equal to 0 for all t. And t ka support is what? 0, 1, 2, n. So therefore g of t is equal to 0 for all t on the 0, 1 to 2n. So therefore g of 0 is equal to 0. G is equal to 0. And therefore xi is complete. Did you understand, guys, the whole proof of completeness? That's why I did it from the first principle. Did you understand, guys? Write a boom. Very good. Superb. Okay. Right. So we have found out that T is complete sufficient. So what is the next step? Once you have found out T is complete and sufficient, we have to find out an unbiased estimate, a function of T, which is the following parameters. Which is unbiased for the following parameters. Okay. So for theta, you know that what? Know that x bar, that is T by n, expectation of T by n is T follows binomial n comma theta. So expectation of T by n is what? Is theta, because expectation of theta. So it's theta. So T by n is unbiased. You see? So what I told, we use this method, some g of t. method. So we have seen that expectation of t is n theta. So we found out on ht, which is t by n, such that expectation of ht is theta. So we have found out the first one. How to find out the second one? How to find out the second one? It's a very important question. How to find out the last one rather? How do you find out for this? So how do you find out for this? So theta to the power 4 के लिए how do you find out? So how do you find out for this? Any ideas, guys? Any ideas? So how do you find out for p to the power 4 or theta to the power 4 ka? Or any theta square ka, how do you find out? Let's do it for theta square. How do you find out for theta square? Let's see it. So it's just extension of that idea. So we will do it for theta square and in the class. For theta square is very so we know that variance is p into theta into 1 minus theta. We know that, right? Variance of that is this. So we know that it's variance of t. Yes, theta into 1 minus theta, right? So its expectation of t square is what? Theta into 1 minus theta plus theta square. Oh, sorry, it's npq. I'm so sorry. It's n. This, right? It's plus expression of t whole square, which is theta square. So you get n theta minus n minus 1 theta. Sorry, it will be plus n minus 1 theta whole square. Sorry. It will be minus n minus 1 theta whole square, right? And you know iska is expectation of np. T is this. So you can find out expectation of t minus t square by n minus 1 is theta square. So you found a function of ht that is this, such that expectation of ht is theta square. So this is the EMV of theta square. In fact, it came in one of the IITs. Did you understand the algorithm, guys? Did you understand the algorithm? We use this method. Similarly, so you can find for theta cube. How? It's very easy. You have found out theta cube. How? You have found for theta. You have found for theta square, right? So now you find out expectation of t cube. Expectation of t cube will be a cubic form of theta. Let's say some a theta cube plus b theta square plus c theta. Okay, plus some d. ऐसा कुछ होगा. So what do? You get that t cube minus b, this one. Let's call it h1, let's call it h2. So minus b h2t minus c h1t minus d, this whole by a is equal to what? Theta cube. So this is a function of t which is an independent of which is a function of whose expectation of theta cube. Hence this is the UMPV. Did you understand the method, guys? The algorithm? Right? Yes, if you understood it. This is how you do the entire problem. Did you understand, guys, or not? Which part didn't understand? Since I see no yes. Yeah, tell me. Hello, guys. I expect some replies. Okay. Others didn't understand? Shana, what didn't you understand? Orko, Mansi, Nikhil, Pratiksha, Proma, Rishabh, what didn't you understand? Tell me. Okay, I will repeat this again next week. Yeah, but you can tell me what didn't you understand. Please tell me. Someone was saying something. Last slide. Can you unmute yourself, China, so that I can help? Like, it will be faster for me.
Sir, this whole last slide, sir, 28th.
Did you understand this part?
Yes.
Did you understand this part?
Yes, sir.
Did you understand this part?
No, sir.
Okay. Did you understand this one? Please unmute yourself. It will be easier for me.
Yes, sir. Yes, sir. Very safety.
Did you understand this?
Yes, sir.
Sure.
Yes, sir.
So this is expectation of t whole square.
Yes, sir. That I understood.
So this is equal to this. So expectation of t is n theta. It's minus this. So our aim is to find what? Our aim is to find the h of t which is unbiased. A function of this complete sufficient statistics which is unbiased. That is the aim. So we have found the expression of t square is equal to expression of t minus this. It's expression of t minus t square by n minus 1 is theta square. Do you understand this, China? No?
No, sir.
Which did you understand this part?
Yes, sir. Next.
So if we
So
subtract
we are
this,
finding the h of t.
so this from this, I take this on the opposite side. You get n minus theta, n minus 1 theta square is equal to x square, and we divide by n minus 1. We get expression of by n minus 1 is equal to theta square. Didn't you get this part?
Yes, sir.
Huh?
Yes, sir. I got it. Yes, sir. I got it.
So we found out the h2 of t, which is whose expectation of is theta square. So it's a UMV of theta square. Similarly, expression of
Okay,
t
sir.
cube.
Read the question carefully.
Huh? Yeah. Hello.
Yes, sir. I got it. Sir. I didn't read the question carefully, sir.
Okay. Similarly, here
Yeah.
expression of t cube can be written as a theta cube plus b theta square plus c theta plus d. Okay, you can understand it's a theta. So what you do is that you replace the theta i's with the corresponding expected values, like expected value of the function of the expected value of h1 of t and expected value of h2 of t, and you get and take all the t values on one side and keep the theta on the other side, theta cube. So you get a function of t which is like whose expectation value is theta cube. So therefore you get a function of t, h3 of t, whose expected value of theta cube. So therefore it's a UMV of theta cube by this result, by the Lehman-Cafe result. Do you understand, guys, all of you? Now, Shana, Orko, Mansi, Nikhil, Pratiksha, Proma, Rishabh.
Excuse me, sir.
Yeah, sure.
Can you please go to the last slide?
Yes.
So here on finding the expectation of t square is equals to variance plus mean square. So sir, here the mean of t should be n theta.
Yeah, mean of t is n theta, right? That's why I replaced by n theta by nt, expression of t.
No sir, on the upper steps.
This one?
No sir, expectation of t square is equals to n theta bracket 1 minus theta plus n square theta square.
Oh, right, you're right. Thank you. Yes, you're right. So it'll be this one, right? Now it's fine. Now it's fine. Rishabh? Oh, it'll be n. Now it's fine. N theta minus n theta square plus n square theta square, so it's n square minus n theta square. ठीक है अभी?
Yes sir. Sir, expectation of t square minus t, one last one.
Oh, yes. Thank you. But yeah, but you got the idea, Rishabh, how to find it?
Yes sir.
Very good, super. So remember these algorithms, guys. Okay, guys. Okay, thank you for the class and perfect. Good night, all of you. I hope you enjoyed the class. Bye.